Hello, my name is Jenny Burridge and I'm Head of Structural Engineering at the Concrete Centre. My talk today is about concrete tall buildings. So a couple of pictures of tall buildings, both of which are concrete or concrete framed. The Burj Khalifa at 828 metres is the tallest building in the world, and the Jeddah Tower is, if it ever gets completed, going to be the tallest building in the world at over 1,000 metres. So, building tall in concrete. Why is concrete the material of choice for those two buildings? Well, it has many properties, some of which work well with tall buildings. For example, it has high thermal mass, which means that the concrete provides a sort of cooling and heating cycle because it absorbs heat and then releases it slowly. This means that there's less in the way of heating and cooling needing to be done in a concrete frame building. Excellent for if it's residential, or even if it's commercial, if it's an office. The other thing it's good for, another good property it has, particularly for residential buildings, is that it has good acoustic properties. It will stop airborne sound getting through and impact sound from one apartment, for example, to another can be stopped by some finishes either on the ceiling or on the floor, but it provides excellent acoustic properties. It also, for the same reason it has mass, high mass, is it's good for vibration, footfall vibration, it's good for, and also for overall vibration, which I'll talk about in a moment. One of the big things that we all think about at the moment, particularly for tall buildings post the Grenfell disaster, is the ability of tall buildings to withstand fire. And concrete is very good in fire. It provides excellent fire resistance. It doesn't burn. It doesn't add to the fire load. It doesn't give off noxious fumes when it gets hot. It provides insulation and integrity, so insulation against fire, heat getting through, and also flame getting through, as well as being an insulation to itself, so that when you have a fire, the inside of any concrete element is kept cool by the insulation of the outside of the concrete element. So it has good load carrying capacity in fire. Now the building regulations only consider life safety, but concrete can provide property protection as well. It's inert, and there are standard detailing rules for concrete cover and for sizes of elements, which have been proven to be very good for fire protection. There is a draft building safety bill in the UK, where it's based largely on the recommendations from the Hacker report post-Grenfell disaster, where there's a new regulatory framework for high-rise residential buildings. It has key roles and responsibilities, or it promotes the use of key roles and responsibilities for people who design, construct and maintain high-rise residential buildings, and that it calls for competency of design, and that such a competency is shown to be existing for the designers, constructors and for people who maintain the building. And it shows that we should have better testing of construction products, all of which are really important. It also provides key dates and stages within the design and construction where you need to show these things have been completed. And it is easier and safer to do it in concrete because of the properties of concrete in fire. It doesn't burn, it doesn't add to the fire load, it doesn't give off noxious fumes. The other thing that we all need to think about, and that is well up in our thoughts at the moment, is the requirement to be net zero by 2050, and even actually to reduce the carbon in the built environment sooner than that. Last month we published our roadmap for net zero in the concrete and cement industries. We are at the moment, the numbers that we have are 2018, and we've already achieved a 53% reduction from the 1990 figures. So within 28 years, we've reduced by 53%, and now we're looking to reduce down to net zero by 2050, and even beyond net zero in some instances. These are the levers that we have that we are using to get to that net zero target. So things like fuel switching in the kilns, having our transport system transporting concrete and cement around with electrical vehicles, so that gives us a -7% reduction. But the big one that we're using is carbon capture, usage and storage. There are some test rigs out there at the moment, and our hope is that by 2050 all the main kilns will have carbon capture, usage and storage within the kiln. The two on the right hand side, carbonation and thermal mass, are to take us beyond net zero, because both carbonation and thermal mass happen anyway, but the use of thermal mass in buildings will reduce the operational carbon, and carbonation happens to concrete. Most of it is at the end of life, but a small amount is during the lifetime of the building. If you want to have any more information on this, then our website, this is concrete.co.uk, has the report if you would like to look at it. But back to structural design of tall buildings. As the building gets taller, we get things that are more important, which concrete can help with. The dynamic components of the wind load and the occupant comfort is one of the things, and I'll speak about that in a moment. We also need to worry about differential vertical movement. Concrete shrinks as it sets and as it gets older, but you have elastic shortening of concrete columns and cores as they go into compression, and the more compression you have, the more the bigger the shortening of the vertical elements. So as that is then compounded by creep within the concrete, you do get quite a bit of shortening. As the building goes up, you will get more shortening. So there is a consideration for differential vertical movement between the columns, which tend to be highly stressed, and the core, which is less stressed. So the recommendation is to put as much load onto the core as possible. This also means that you have a more stable building as the core is the stiff bit that you're wanting to achieve. Column restraint and foundation behaviour and capacity are also considerations within the structural design. The dynamics, mostly the lateral dynamics, so the sway of the building is more important in tall buildings. As you get more sway, as you go taller, you need to think about wind and seismic forces. Seismic, particularly if you're in a seismic area, but wind all the time. And in the UK, wind is the one to be considered most. Keeping all the vertical elements in compression, as I said, will result in a stiffer building, and that will also enable you to use the high degree of natural damping in a concrete building. So I'm going to look just a bit about core construction in a concrete frame building. Cores quite often are concrete, whether they're in a concrete frame building or some other type of building, steel or timber, because the core provides that fireproof means of escape, and it also provides this good damped, stiff element in the middle of or tends to be in the middle of the building. The options that we have for concrete core construction in the UK, slip form, jump form and twin wall. They're the main ones that we use for tall buildings. So slip form, this is quite an old photograph now. It's the slip formed core of the Shard buildings that obviously has been completed some time ago. And that was slip formed from ground floor. It was the first time that has been used, with top down construction done for the basement. It's been used that top down, but starting slip forming above at ground floor has been used for other buildings since. But this was quite a good way of doing the Shard. And some more photos from the Shard. Slip forming is where the formwork is jacked up the building slowly. It's about 250 millimetres per hour. The best way of doing slip forming is at 24-hour working, but that's quite often not possible. But there are ways of stopping and starting at the beginning and end of each day. And the formwork is jacked up the building, or the core, while the reinforcement is placed, the concrete is poured, and the concrete goes off and gains strength. It's done. It is a very quick way of doing it, but doesn't give you very good finishes. Jump form is the way of getting better finishes. It's done normally as a story height by story height formwork system. Normally done about as a 4-day cycle, so that every 4 days the formwork is either jacked if it is self-climbing system, or brought up by a crane if it's not, to the next story, and then it's done. So it's done story by story. So jump form gives you good finishes, but doesn't go up as quickly as slip form, and is normally the one that's used for residential buildings. Twin wall is one not used so much. It's what we call a hybrid concrete construction, which is precast and in situ concrete together. The external parts of the formwork, so it's precast concrete as permanent formwork, but also part of the main structure, and it goes up very well and has good finishes. Here are some of the attributes that are good for slip form, jump form and twin wall. So slip form is fast, twin wall gives you excellent concrete finish, jump form will give you can give you wide core walls if you need to. Very quick case study on this is the 432 Park Avenue in New York. It's at a core, but the external wall is also part of the stability system. It's a concrete frame building and is currently the third tallest purely residential building in the world. It is very, very slender at 15:1, so the height to width is 15:1. We tend to say that tall buildings are bigger than 5:1, so this is super tall and super slender. It was done with in situ concrete construction, pumped from street level, so it has high strength concrete. I'm just giving you some places to look for further reading on concrete tall buildings. The one on the left is a technical guide on concrete tall buildings written with FIB International. That's available from our bookshop. Our summary of that technical guide is in our concrete tall buildings brochure, which is free from our website, and also free from our website is a series of case studies that have been in our Concrete Quarterly magazine, and this brochure is also available for free from our website. And that finishes my talk. Thank you very much for listening. I hope you've found that useful. If you have any questions, there's Q&A afterwards, and here's my email address if that helps.